Hey Panthers, we are continuing to look at section 12.6. We have so far done inequalities. We've looked at what an inequality is. We've talked about how to say an inequality. We've talked about how to graph an inequality. We have talked about how inequalities are similar to solving equations. So we've been doing adding and subtracting, and today we are looking at multiplying and dividing. Now this table should be filled out in your notes as we fill this out in class on Friday. If it is not filled out in your notes, please pause me right now and go ahead and fill it out. So we filled in this table on Friday and we noticed a pattern. Basically what it's saying is if I were to multiply both sides of my inequality by 2, I would now have 6 is less than 8, which is what? True. That is a true inequality. However, if you take a look at this one, if I were to multiply both sides by -1, I'd have -5 and -2, and my inequality would state that -5 is greater than -2, which we know is false. So when we have the positive numbers, we notice the answer is always true, but when I have the negatives, it becomes false. Same thing if you scroll down to the dividing section. You see the negative ends up giving you a false inequality, and the positives, when you multiply or divide both sides by a positive number, the inequality remains true. Therefore, we came up with some rules in class on Friday. Okay. And these are on your sheet. Rule number 1, when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. In other words, all you have to do when you solve is bring down your inequality sign. You don't have to change it. However, with rule 2, when you multiply or divide each side of an inequality by the same negative number, and again, I have to reiterate, this is only true for multiplying and dividing by negatives. When you multiply each side or divide each side by the same negative number, the inequality must be flipped for the inequality to remain true. Okay. So let's take a look at some sample problems. Letter A, we have, if we read it, 9 times x is less than or equal to 54. So again, we want our variable on the left, which it is. And in order to get our variable alone, we're going to have to do some inverse operations. Here, x is being multiplied by 9, a positive 9, and therefore we have to do the opposite or inverse and divide both sides by a positive 9. Okay. And our inverse operations cancel out, and we're left with x, and 54 divided by 9 is 6. Now here's where you need to stop and think. Did I multiply or divide? Yes. Is it by a negative? No. Therefore, I can just bring down my inequality sign, and we get the final answer that x is less than or equal to 6. Remember, for checking your answers, once you get your answer, find any number that's less than or equal to 6. On Friday, I told you whenever you can use 0, it's probably the easiest one. So I'm going to choose 0, and I'm going to plug 0 back into my original inequality. And 9 times 0 is 0. And is 0 less than or equal to 54? Yes. Okay. So again, we're not going to check every single possible answer, but pick one and plug it back in and make sure it works. Basically, what you're checking is to make sure your inequality is facing the right direction. Okay. Take a look at B. B, our variable, again, is on the left, which is good. Remember, a fraction bar is the same as dividing. X is being divided by a positive 9, therefore we need to do the inverse operation and multiply by a positive 9 to both sides. Make sure you're writing this down. Our inverse operations cancel out, so we're left with x. And over here we have negative 4 times 9. Now, some students think, oh, they see that negative and they think, oh, I have to flip the sign. You only flip it as if your inverse operations you're multiplying or dividing by a negative number. Only the inverse operations. So this is positive 9, so we get negative 36. And again, because we multiplied by a positive for our inverse operation, we just have to bring the sign down, and we get an answer of x is greater than negative 36. So choose a number that's greater than negative 36. Again, I'm going to choose what? 0. Okay, so if I plug 0 back in, I get 0 divided by 9, which is not really a good number to choose. But would that be greater than negative 4? Yes. Okay, take a look at C. Draw my line. X is on the left, that's good. X is being divided by a negative 5. The inverse operation of dividing is multiplying. And again, same number. So we're going to multiply both sides by a negative. This is where your bells should be alarming. Okay. Our inverse operations cancel out, and we're left with x. On the right, we have 7 times negative 5, which is what? Negative 35. And again, did we multiply or divide for our inverse operation? Yes. Was it by a negative number? Yes. Therefore, we need to reverse our inequality so that our answer is x is less than or equal to 35. Again, is 0 less than or equal to negative 35? No, 0 would not work this time. We have to find a number less than negative 35. So again, we're going left on the number line. Maybe negative 100. What's negative 100 divided by a negative 5? Positive 20. Positive 20. So if I plug it in up here, is positive 20 greater than or equal to 7? Yes. Okay. And letter D. Our variable's on the left. X is being multiplied by a negative 3, so we have to divide by a negative 3. Our inverse operations cancel out. We're left with x. Negative 27 divided by negative 3. I've got an even number of negatives, therefore my answer is going to be positive 9. Oh, I don't need that equal sign there. So used to doing equations. And again, looking at your inverse operation, or your inverse operations. Did you multiply or divide? Yes. Was it by a negative number? Yes. Therefore, we need to reverse our inequality. So our answer is x is greater than 9. Think of a number that's greater than 9. I'm going to choose 10. If I plug in 10 back up at the top, what's a negative 3 times 10? Negative 30. Is negative 30 less than negative 27? Yes, remember your negatives. Think about it as owing somebody money. Would you rather owe somebody $30 or owe somebody $27? Who has more money, even though they both have none? Okay. Moving on. I'm going to skip these. Actually, yeah, let's skip these. Go ahead and write skip on your notes. A lot of the same problems. Let's take a look at the story problems. Example 2. Martha earns $9 per hour working at a fast food restaurant. How many hours must she work in a week to earn at least $117? Okay, think about your crucial numbers here. Go ahead and circle them. $9 and $117. We have this $9 per hour, which is something you should be quite familiar with at this point. If I were to write that out, when we talk about $9 per hour, we're taking 9 and multiplying it by the number of hours worked, or 9 times h, or just 9h. So Martha gets paid $9 multiplied by every hour she works. We have to figure out what h would be so that in a week she would earn at least $117. When I say at least, does that include $117?
Yes.
Yep. So we have our half equal sign. And do we want, again, the left side represents the money she's made. Do we want the left side to be greater than or less than 117? Yeah, she's all right with earning more money than that. That would be good. Now this is a good problem if you're ever, when you're growing up, and even now you start budgeting your money, or there's something on sale somewhere, or something that you want to purchase. And you have to do so many chores in order to make enough money. So again, we've talked about these types of situations when we use equations. But is it a bad thing to earn more money than what you need? Not at all. Okay, so this, when you're talking about earning money, inequalities are actually more appropriate because it's all right to earn more rather than make exactly 117. And example 3. It cost Josh $85 to make candles for the craft fair. How many candles must he sell at $4 each to make a profit? I want you to underline the word profit here. This tells us what our inequality is, believe it or not. Okay? When you want to make a profit, what does that mean? Think about it. Does it mean you break even? No. There's your key. You don't break even. Okay? So we're making candles. We're selling them for $4 multiplied by every candle that's sold. So 4 times C. Now he spent $85 for this project, and he's going to a craft fair, which obviously he's going to be selling these. Now again, I'm going to ask you that question. If he wants to make a profit, does he want to break even with $85? No. Okay? So the left side represents the money he is making, and the right side represents the money he spent. Which one needs to be greater? Hopefully you're saying the money he's making at the fair. Okay? We want 85 to be the lowest amount possible. And we don't want it to be equal to 85 because then he made no profit. Profit has to be he made more money than he spent. Okay? And what I would like you to do right now is this last problem here. We have an inequality, a one-step inequality, dealing with multiplying and dividing. Go ahead and look over it and try to find, number 1, where the student made their mistake, and I want you to write a sentence explaining it. Don't just circle it or highlight it. Say the student did this and they should have done this instead. And then go ahead and from the point where they made the mistake, fix it and finish it correctly. Thank you.